Good morning to everyone. Today we're going to be looking at the first lesson in topic 2. In topic 2, I think we'll enjoy this one, maybe even a little bit better than we did topic 1. We're going to be talking about linear equations and how to graph them using different types of formats. And in the first lesson, 2-1, we're going to be talking about a very well-known and famous format known as the slope-intercept form. Before we get started, though, I want to go ahead and look at some of the vocabulary. If you notice over here in your little bubble, the vocabulary words are slope-intercept form and y-intercept. I'm going to speed down here towards the bottom and address both of those right here. Okay, so the slope. We talked about the slope a bit last year when we had pre-algebra together. The slope is simply referring to a line, and I'm just going to draw just a line here, a couple of them actually. We'll put one this way and one this way. If those lines were on a graph, say that we figured out how to graph those onto a graph, which we're going to be talking more about today, and let's say that the slope or the line looked like this first one up top here. The slope determines the steepness of a line. Okay, so how steep is your line? Same with this one. Okay, when you're thinking about the slope can either be going from left to right in a positive direction, or it can be going from left to right in a negative direction. So you can have a positive slope or you could have a negative slope. We have to determine what the slope is, though. We don't always know it just by looking at a line, but we do have a format that we can use to figure that out. When you're thinking about whether a line is positive or negative, be careful with that. I always tell students, always start at the left side of your line. So in this case, right here, and in this case, down here. Think about your eye being right here at the bottom of this line, and you're looking up this way. If you're going in an upward motion, you're going in a positive direction. Same is true for this side. If you have your eyeball positioned at the left side of your line and it's heading downward, then you're heading in a negative direction. So your slope can be either positive or negative, and remember, the slope determines the steepness of your line. A y-intercept is where a line crosses. So for example, let's just put this line on here. It's where your line crosses on the y-axis, okay? There's also something known as an x-intercept, and that would be where the line crosses on the x-axis. But today we're mostly concerned with the y-intercept because that is going to be a part of our equation that we're going to be talking about today that we must know. So always remember that. It's where our line crosses on the y-axis. Okay, so if you think about that, let's just say this is our points right here. This is at 0, 2. Remember, this is x. If we have a coordinate point, we always have an x value and a y value. So in this case, it's 0, 2. X tells us how far we're counting left to right. And in this case, look, we always start at the origin, don't we? I'll put an O there for origin. I'm not going to go left or right at all to get to this point up on the y-axis, but I am going to travel up 2 steps, and that is the y value. Okay, so 2 would be our y-intercept here. We'll talk a little bit more about that when we get to the example, but 2 is what the y-intercept is in this case, okay, because it is where the line crosses the y-axis, and we always refer to the y-intercept as the y value in our coordinate point there. Okay, so let's go on. I'm going to start actually, whoops, I passed where I want to start here. In your book, it starts out with this little example here to start our lesson out. So let's take a look at this illustration. You see this, it appears to be a boy. It's the shadow here, so it's kind of hard to tell, but when I look at the hair on his head, it looks like it could be a boy. Who knows, maybe it's a girl with short hair, but at any rate, they're heading in a downward direction. Okay, so I can tell that there's a steepness here or a slope. It looks like it's going in a negative direction, right? I'll just put a little negative sign there like so. What's happening in this picture? If I look at the bottom here, it says weekly bike payments, and I see that we have several weeks here, 5 weeks to be exact. And I notice that the first block here indicates the full price of a bicycle, and then the second block here refers to an amount that this person is going to put down when purchasing a bicycle. So let's say this person goes to the store, they buy a bicycle, this is the full price of it. So in graphing this into an illustrative way of seeing this, you have your full price there to the left, and then you can see your down payment. So this person isn't going to give the whole amount of money for the bike. They're going to put a down payment down here, and then there's going to be a balance that has to be paid over time. Now, they could buy the bike in a full amount if they wanted to, but perhaps their allowance isn't big enough to allow them to do that. So they're going to give a little bit in a down payment and then pay the rest off in 5 weeks. Okay, so they'd have to divide out what is left to be owed, and they would pay that off in 5 weeks. Okay, we are going to come back to that drawing at the end and ask a couple quick questions about it as we learn more about this lesson. So let's go to the top. You should have your recording form there for lesson 2-1 notes, and if you follow along with me and taking some notes, that would be great. Let's look at example number 1. The first thing that we are going to do, first of all, let me tell you your objective here. At the end of this lesson, you're going to be able to write linear equations in 2 variables using the slope-intercept form to represent the relationship between 2 quantities, and then also you're going to be able to interpret the slope and the intercept of a linear model. So in example number 1, the first thing we're going to do is graph a linear equation. So you notice you have a coordinate plane here off to the right, and off to the left here is some informative information for us. The slope-intercept form is extremely important in this lesson, and we're going to be referring back to this quite often. We're going to be looking at different parts of the equation, how we can solve for certain parts of it if we only know a couple things about it. So we're going to be very versatile with this particular format today. Okay, so the first question we have for ourselves is, what is the graph of this equation right here? Y equals 4/5 times x plus 2. Well, the first step here we want to do is we want to identify and graph the y-intercept. Now, remember what I said about the y-intercept. It's going to be a point that lies on the y-axis. It's where your line crosses the y-axis. Well, did you know that I can look at this equation and determine what that number is? This letter B right here in this format is always, always, always going to be your y-intercept. So I know that this 2 is my y-intercept. So if I have to graph that, it's going to be at 0, 2. Interestingly enough, I use that as an example at the bottom, not on purpose, but we did it, so there we go. So let's go ahead and plot 0, 2. Make sure that you label that as so. Okay, so B is always the y-intercept, and you'll notice I have all of those in blue. If you have some colored pencils handy, that could work in your favor if you want to do a little bit of color coding to help identify parts of this. Okay, so the y-intercept is 2, and knowing that, we can graph it at 0, 2. It's where our line is going to cross the y-axis. Step 2, we're going to use the slope to plot the second point. In the format y equals mx plus b, the slope is always m. Always. Okay, this is going to be a universal form that you're going to use for many years to come. You're just going to always, eventually you're going to know that y equals mx plus b. It's just something you're going to know. But for today, we're going to learn it a little bit more in detail. Okay, so the slope is always m, and we use this to plot the second point. Okay, so I look here, and I notice that the m value in my slope-intercept form happens to be 4/5. Okay, bump down here with me where I have some pink writing right below step 2. What the slope indicates, remember, it's the steepness of the line, but it's more than just that. We have to have some way to figure out what the slope is. Well, the slope is actually the vertical change. It's a ratio of the vertical change over the horizontal change. So if our slope is 4/5, you want to fill that in. It's the vertical change over the horizontal change. It's also commonly known as rise over run. You're going to hear that a lot too. So let's see what that looks like. So I can actually, knowing that I have that information in my slope-intercept form, I have the 4/5, I can figure out where to plot that second point, and then I can draw my line. So let me show you how that's done. So we always started our y-intercept, which was over here on the graph, at 0, 2. If our slope is 4/5, and keep in mind, remember I said a slope can be positive or negative. Well, in this case, 4 over 5, they're both positive. So my line is going to be going in a positive direction, and my rise is going to be going in a positive direction, and my run is going to be going in a positive direction. So what does that mean? So let me show you. So we started our y-intercept, so you're going to want to put your pencil over here on your y-intercept on your graph, and you're going to want to rise. So you can rise in a positive direction, you can go this way, or you can rise in a negative direction. In this case, since our slope is positive, we're going to be rising in a positive direction. So starting at my point at 0, 2, I'm going to put my pencil on that point, and I am going to rise with my red pencil 4, that's what it says over here. We're going to rise up 4 steps. 1, 2, 3, 4. Okay, that is part way to identifying the steepness of my line. Okay, that's this part. That's the vertical change. Now let's figure out the horizontal change. The horizontal change is 5. So from where I just landed here, I'm going to change my pencil to blue. I'm going to go over 5 steps. I'm going to run, and just like we can rise in a positive and negative direction, we can run in a positive and negative direction. I can either run this way or I can run this way, depending what my slope is. But since our slope is positive, we're going to be running in a positive direction. So from where we left off here, we're going to go 5 steps to the right. We're going to run in a positive direction 5 steps. 1, 2, 3, 4, 5. Right there. And I'm going to plot my second point. I'm going to go back to red. Now, from that, I've got to figure out where is that? What's the address of that point? All right, so now I just have to figure out where that point is. So I go back down to my graph here. Remember, this is the origin down here with O. So I go over 1, 2, 3, 4, 5 over, and 1, 2, 3, 4, 5, 6 up. So that point lives on my coordinate plane at 5, 6. That's its address. Okay, now I have 2 points. I can graph my line. If you have a ruler, you might want to do it nice and neatly. I can't put a ruler on my iPad. It makes funny things happen. So I'm just going to do the best I can. Cutting through here. Okay, so there is my line. Notice I said that our slope over here was positive. And remember I said if you put your eyeball over here, and if I head upward from the left of my line to the right of my line, if it's heading upward, it's a positive slope. And we knew that the slope was positive, but it also shows in my graph actually does reveal a positive sloped line. Okay? All right, so that is how we use the slope-intercept form. If we have an equation that is in the mx plus b format, we can pull parts of that out to graph 2 points on a line and draw our line. Okay, so if we know the slope and we know the y-intercept, we can successfully plot a line. That's all you need is 2 points to graph a line. All right, number 2. We're going to write an equation in slope-intercept form from a graph. So what I want you to do here, I'm going to have you actually graph on your coordinate plane. We're going to do some graphing here. So I want you to put your first point is going to be at 0, 1, and you're going to label that 0, 1. And then I want you to go to 4, negative 2. So 1, 2, 3, 4, negative 2. And I want you to label that. And then I want you to go ahead and connect those points to make your line. Oh dear. Hold on a minute, I got a little bit shaky there. All right, so there's what our line looks like. Now by looking at that, you can already determine if your slope is going to be positive or negative. Remember what I said? You go to the left side of your graph, your line. You put your eyeball there because that's where you're looking. You're looking from left to right. This is heading in a downward motion. It looks like we're going to have a negative slope, doesn't it? I'm just going to make a little note of that up here so I don't forget that I've already checked that out. So hopefully when we finish this, our slope ends up being negative. That's what we're hoping to see. Okay, so the first thing that we're going to do is notice here, I do see that we have our y-intercept, but let's go ahead in step 1 off to the right here. We're going to find the slope between 2 points on this line. We have 2 points. We're going to write down what those 2 points are. We're going to write the first one is 0, 1. Okay, and you notice below there, you're going to see an x1 and a y1. I'm going to explain that to you in just a minute what that's about. And then the other point is 4, negative 2. Okay, so there's our 2 points that we have enough information now from looking at the graph to be able to figure out the slope. And I'm going to show you how we do that. And then we're going to be able to write an equation to match the line that's on our graph. Okay, so I have 2 sets of points. Okay, they both are x, y, right? I always said we know that when we have any set of points, there's an x value. And when we're trying to plot that, we're going this way on our graph. And then with our y value, we're going to be going in a vertical direction to plot that point. Okay, but because I'm dealing with 2 sets of points here, it's not going to be just an xy and an xy. We're going to actually call these, because I actually have 2 sets of points. So we're going to call these on this side x1 and y1. And the second set of points, since it's another set 2, we'll just give them a little sub number of 2 here, just to keep our set of points distinct, okay? So let's look here. By knowing that now, let's look down here at how do we figure out the slope. Well, remember, the slope is simply a ratio of the change in y, the vertical change rather, which is the change in y over the horizontal change. Remember that? Let me just bump back up here real quick. Right up here, remember where we said that? That's what the slope means. It's the vertical change, and that's what we did when we drew our lines over here on the graph in red and blue. It's the vertical change over horizontal change. That's what the slope is. We can also say it's rise over run for an easy way to remember that. Okay, so what we're going to do here is we're going to plug in our values that we have from our set of points for our slope. So it's rise over run, but what we're going to do here is we are going to plug in our values for y2 and y1. So where is y2? Let me erase this here real quick. I'm going to highlight this. So I have y2 and y1. They're going to be coming out of 2 different sets of points. And here is y1. So I'm going to just kind of color code those here so you can see them. Okay, so we have y2, which is negative 2, minus y1, which is 1. And then let's use the same color coding here for x1 and x2, and let's fill that in. So in my graph, so I have x2 and I have x1. So let's match those up. So x2 is 4 and x1 is 0. So I'm just substituting them in to this slope formula right here. So this is a way to find the slope. We have 2 sets of points. If we find the vertical change, which is y2 minus y1, over the horizontal change, which is x2 minus x1, 2 sets of points, and we subtract those, we can figure out what our slope is. So negative 2 minus 1 is negative 3. Oop, remember I said it looks like we're going to have a negative slope here. Over 4 minus 0, which is 4. So there's our slope. Now, I'm going to just show you how that actually is true. So with your 2 sets of pencils here, we're going to start at the y-intercept on our graph. I'm going to take my slope. I'm going to write the slope over here so we don't forget what it is because I want to expand my screen here. Okay, here we go. Okay, so the slope is negative 3/4. Okay, we always start at the y-intercept or one set of points. It doesn't matter. We may not always have the y-intercept. It might be a different point. All right, we're going to start there. And remember, this is rise over run. In this case, we're going to rise in a negative direction. We always think of rising as getting up out of bed, so you're rising in a positive direction. But when you go back to bed, you're kind of rising back down into a negative, back into the bed in a negative position. So rising can be positive or negative. It's just a term to think about going up or down the y-axis, okay, or up and down the y vertical change. All right, so here we are at the y-intercept 0, 1, and we're going to rise down 1, 2, 3 steps, and then we're going to run, and this happens to be a positive 4, so we're going to run in a positive direction 4 steps. 1, 2, 3, 4. Look at that. That really, truly does work, doesn't it? This was 4 steps, and this one over here was heading downward 3 steps. That's our slope. The change in y over the change in x, okay? Or the vertical change over the horizontal change. That's how we find the slope. That's the steepness of our line. Okay, so now we successfully figured out our slope. Now we want to find the y-intercept, and we see that it's already there on the graph. The y-intercept was right over here at 0, 1. And remember, the y-intercept is the y value of that set of points. So it's the 1 that's in that set of points. Now, above this box, or actually, I need you to write in step 3. I failed to put that in there, so I'm going to write it in black here. If you'll just fill this in with your pencil. Step 3 needs to say, write the equation. And we're going to do that right over here. Okay, so the equation, we're going to still use the slope-intercept form, which is, and I want you to write this right above here. I'm going to put it in black here, or maybe I'll use green. We're going to use y equals mx plus b. Okay, now let's go ahead and I'm going to take my red pencil and we're going to fill this out. Okay, so y equals the slope, which we said was negative 3/4. And actually, remember, if there is one negative in a fraction, it makes the whole fraction negative. So I can actually write this as negative 3/4 plus b, which is always our y-intercept, which is 1. And that's how we accomplish that, by looking at a graph and figuring out what parts we have that we can fill out and calculate. Perhaps we might need to do some calculating like we did on the slope here to figure out how to write the equation. Okay, now on number 3, we're going to understand slope-intercept form, how to find an equation of a line that passes through 2 points if neither of those is the y-intercept. And I mentioned that just a moment ago. So this is going to be 2 sets of points, and you'll notice right up here we say consider the line that passes through the points -1 and -2, and -1, -2, and 3, 4. Okay, so I have these color-coded for a little bit later, but let's go ahead and notice we have 2 sets of points. Okay, so we are gonna, this is an x value, and this is a y value, and this is an x value, and this is a y value. But since I have 2 sets of points here, this is gonna be x1, y1, and this is gonna be x2 and y2. Okay, just to kind of separate our points. Because if I call them both x, y, I really won't know which set of points I'm referring to. So when we have 2 sets of points that we're dealing with in any equations or formulas that we have to fill in, we need to identify them and give them their own individual identities. Okay, so the first thing we need to do here, and we're not going to graph this, we simply are going to figure out what the y equals mx plus b format at the bottom here. You can write that right here, y equals mx plus b. So we're looking in the end of this, we're going to figure out all the parts that are needed to write the slope-intercept form for these 2 points when that's all the information we have. You see, without the y-intercept, it's going to be hard for me to figure out what b is, but we're going to figure that out in step 2. So the first thing we want to do is we got to figure out what the slope is, because I don't even know what m is. And remember, m is the slope. Okay, always. So let's go over here to step 1 and let's figure out what the slope is. All right, so I'm going to take my values here from my set of points, 2 sets of points, and I'm going to grab y2, which is 4, minus y1, which is a negative 2. Be careful now. 4 minus a negative 2. x2 is 3, and x1 is negative 1. Again, be careful. It's not just 3 minus 1. It's 3 minus a negative 1. Okay, now let's solve that. We're going to have 4. Remember, when we subtract a negative, it's the same as adding. So in both cases here, we're going to be adding those. We're going to end up with, I'm going to come down to the bottom here, so I don't want to write into the next step. So I'm going to have 6 over 4. I can reduce that to 3/2. So here's my slope. So m, which is my slope, is 3/2. Okay, so I've already got part of this. So I'm going to go ahead and fill in what I know down here. I have 3/2 x. Now we have to figure out what b is, what the y-intercept is, because it's not given to us. We don't have a set of points provided for us that are falling on the y-axis. Well, there is going to be one, but we don't know, by looking at the points they give us, we don't know what that is. Now, there's a good possibility that you could actually graph the points that are given to you. -1, -2, let's say it's down here somewhere, -1, -2, and 3, 4 up here. So you can see it is going to cross over. Now, that's not accurate, obviously. If I had a better grid, I might find a more accurate y-intercept. But, you know, you can't just trust your eyes in something like this. So we have to use what math we know and formulas that were given to figure this out exactly. Okay, so let's use the slope that we discovered, which is 3/2, and one of the points that are given up here to find the y-intercept, which is the b part of our formula. All right, so I'm going to fill in my slope here. We said the slope was 3/2. So we have 3/2 x plus b. I don't know b. B is our y-intercept. Okay, I am going to pull though. Oops, actually I want to get rid of this x. Hopefully you're using a pencil so you can get in there and erase. We're going to figure out a value for x and a value for y. Okay, I'm going to look at either one of these points up here, either the -1, -2, or the 3, 4 that's given as given information in our problem. I'm going to just pull the 2 positive ones, the 3 and the 4. The y value is 4. I'm looking right up here, guys. And the x value is 3. Fill those in. I could have used the other set as well, but I'm just going to go with the easier ones because they're positive. And I'm going to multiply this out. I have 4 equals, I need to put my slope back in there. I'll do it right here. 3/2 times 3. I should have put it in up there, but I know if I try to erase it, I'm going to end up erasing the whole thing. I think, let's see if I can do it. Yep, just like I thought. Okay, guys, be patient with me. I'm sorry. 4 equals 3/2. And what did we say the x was? The x is 3. Plus b. Okay, let's do the multiplication here. 4 equals 9/2 plus b. I'm going to change that 4 to something over 2. That's going to become 8 over 2, right? Because it's 4 over 1 equals 9 halves plus b. Let's subtract 9 halves from both sides. That gets rid of them on this side. I'm isolating b so I can figure out what the y-intercept is here. And I'll have a negative 1/2. So this is my y-intercept. So now I know what b needs to be in my equation over here. b is negative 1/2. Okay, so we can actually just get rid of the plus sign here and put, because the slope is negative 1/2, so really it's subtracting 1/2. And if you think about, is the slope positive or negative? Well, it says it's negative, and when I tried to sketch it out over here for you, I'm going to put these points on here really quickly again. -1, -2 was like maybe down here, and 3, 4 was maybe up here. Wait a minute here. I don't think I did that right, did I? -1, -2, 3, 4. That's going in a positive. I don't like that. Hold on a minute. Oh, I'm sorry. I'm talking here. Goodness gracious. Hopefully you're over there going, no, Mrs. Quigley, wait. I hear what you're saying and you're not right. Okay. Anyway, when that line was graphed, it would have gone like this, right? I'm saying the slope is negative. The slope isn't negative. The slope was 3/2 over here. This is the y-intercept here. Okay, so remember when I graphed it, it was going this way. If I put my eyeball down here, which way is it going? It's going upward in a positive direction. And our slope was 3/2. Remember, the slope is actually m right here. Okay, so all of these things tie together to speak a lot of things about our graph and our equation in slope-intercept form. All right, guys, here comes the fun part. Looking at a word problem. So how do we apply this to a real-life situation? Let's look at this. Allie received a gift card, and this is actually in your book. If you wanted to turn there, you certainly could, but I have all the information you need here, but this is on page 59 in your textbook. Allie receives a gift card for her local coffee shop. Every time she goes to the shop, she orders a medium coffee. The graph over here on the gift card, you're going to notice on the side of the gift card here, they actually have a little gridded graph here for us. The graph shows the gift card balance at 2 points. Okay, so what they're saying is these are balances here. Okay. So the graph shows the gift card balance at 2 different points. How can Allie determine the number of medium coffees? Okay, so that's what we're going to figure out in the end, that she can buy with the gift card if she doesn't even know what the original value of the card is. So think about that. How many times have you gotten a gift card and perhaps the person who gave it to you forgot to write on there how much it was? So you go to use it and you really don't even know. Now maybe you got smart and you turned the card over and you took the 1-800 number off the back and you called it in and you punched in the numbers of the card and you were able to get an automated voice telling you how much was on your card. Well, that's all well and good, but maybe back in the day, maybe they didn't have phones with push buttons to do that. I don't know. Or maybe somebody just wants the challenge. I know right now we want the challenge. So let's figure out, how can we figure out how many number of medium coffees Allie can order when she doesn't even know how much is on her gift card? Okay, but we are given some information here that's very helpful. So 2 points are graphed here, and they are at 2 and 19.7. The second point is at 4 and 14.4. So the first thing is we need to interpret the meaning of those 2 points. Well, let's look at the graph. The bottom here shows these are the number of medium cups of coffee she's ordering. So they're skipping it by 2s. So here's 2 cups of coffee. As I'm down on the, we'll call this the x-axis, see where the x is here. So on the x-axis here, we have 0 cups of coffee, 2 cups of coffee, 4 cups of coffee, 6, 8, and 10. Okay, and then off to on the y-axis over here, we see that the gift card balances are represented on the y-axis. So the balance is at $4, $8, $12, $16, $20, and $24. Okay, so those represent balances. Okay, so X is the number of coffees. Y's are the gift card balances. So when you're thinking about this, when we're looking at these points, 2 and 19.7 down here in step 1, you want to fill this in. 2 represents 2 coffees, or 2 cups of coffees, 2 cups of coffee. And the 19.7 represents the balance. After she has 2 cups of coffee, her balance is at $19.70. Likewise, at 4 cups of coffee, or 4 coffees, I'm going to call it, her balance is now $14.40. So one thing makes sense here, doesn't it? It shows that every time she orders a cup of coffee, her balance is going down. Well, that makes sense. Well, I wonder what the slope of that is. What's the steepness? What is the ratio that's going to be shown to show how quickly that is declining? At what rate is that declining? Well, step 2 is going to help us know that. So we're going to do what we did in the last couple of problems, where we have 2 sets of points. We have, remember, 2 and 19.7 and 4 and 14.4. So we have a Y2 and a Y1 and an X2 and an X1. So in case you don't remember what I'm talking about here, I'm going to go over here and label those. This is going to be our, let me just make sure I'm keeping in consistency here. Y2 is 19.7. Okay, so here is, I'm going to actually label them this way. X2 and X1. It doesn't really matter which set you call 1 and which set you call 2, but you just want to identify them as such because you are dealing with 2 different sets of X, Y values in the same problem. Okay, so knowing this, let's fill in Y2 minus Y1. Well, Y2 is 19.7 and Y1 is 14.4. Remember, this is the vertical change. This is the slope over the horizontal change. X2 is 2, and X1 is 4. Now, you do need to make sure you're putting them in the same order. So if Y2, it's always Y2 minus Y1 and X2 minus X1. So always be pulling from the correct set of points. That makes a big difference. You can't just haphazardly pull an X and a Y. They're coming just as you labeled them. That's why it's important to identify those ahead of time. When you do the math on this, you're going to end up with 5.3 over -2. I can already tell my slope is going to be negative, and I already knew that, didn't I? On the card, I can already tell it's heading downward in a negative slant. And when I put this in my calculator, I'm going to end up with -2.65. What does that slope mean in relationship to the story? Okay, well, the balance on the gift card, we said, is declining or decreasing. That's the first thing we want to kind of think about. And I already said that when I drew the line over there and showed it at a negative slope. How much is it declining by? Well, the slope says it's declining by $2.65 or 2.65. It's going down. Each set of points there is decreasing. Every 2 cups of coffee is decreasing $2.65 worth. All right, so the cost of a medium cup of coffee is $2.65. Okay, step 3, we want to use 1 point and the slope to find the y-intercept, because what we're going to do here is we are going to figure out what the beginning balance was so that now I can figure out how many medium cups of coffee Allie can purchase. Okay, so we have this formula, y equals mx plus b. I'm going to fill some things in here. I'm going to grab a set of points. I'm going to highlight those for you in yellow. And we're going to pull, let's use these right here. In my mx plus b, in step 3, I'm going to take one set of points and I'm going to fill in for y. I'm going to use 19.7. My slope, I said, is negative 2.65. My x value over here in my set of points is 2. Over here where I highlighted in yellow. Didn't matter which set of points I pulled from, I just chose to pull from the first set. No reason. I could have used the second set. I could have used 4 and 14.4 for x and y, but I'm going to use these plus b. Remember, we're looking to find the y-intercept so that I can write an equation down here. And to figure out, because the y-intercept actually means something in the story about the gift card. Alrighty, so let's do our math here. You're going to end up with 19.7 equals a negative 5.3 plus b. If I add 5.3 to both sides, b is going to equal 25. Okay, so the y-intercept then is 25. And this represents the original value of the gift card. So out here to the right, go ahead and put $25. That's what that means. So if I go back over to my graph, the original balance on my card would have been at 25. So these are skipping 20, 22, 24. So 25 would have been like right in between here. That's the original value of my card. Now let's write an equation to represent this information here. So remember, we're using y equals mx plus b. Let's just fill in our parts. We always leave y by itself. Our slope was negative 2.65. And our y-intercept is 25. Okay, so with this particular word problem, we can figure out some information. Now, what they wanted to know up here is how many number of medium cups of coffee is Allie able to order. So up here at the top, let's just go ahead up here and squeeze in the answer to that. How would I figure that out? Now think about it. If there's $25 on the gift card, and every time I go order a cup of coffee, it cost me $2.65. How would I figure this out? If I take my total amount, think about this. If I take my total amount and I divide it by the cost of a cup of coffee, shouldn't that tell me how many cups of coffee I can get? If you put that in your calculator, it should come out to 9 cups of medium-sized coffees. Yes, that is a lot of information, but it's important for us to know. Okay, I am going to cut this off at this time. You're going to notice down here another problem. I had that one on there originally, but I want to leave that for us to do another time. So don't worry about doing this one down here. Don't worry about doing that one. I'm going to say do not do. Don't put a big X through it or anything like that. We'll do it at another time. So coming back to this question at the beginning, let's see. It looks to me then like this down payment would be represented by our y-intercept, right? This amount right here would be the y-intercept. So when I figure out some more information about this, now I don't have enough because I don't even know what the down payment is. There's a lot of variables here. Okay, but that would represent our y-intercept right here. Okay, so that sums everything up. I'm not going to work through these examples with you right now because I don't want to take any more time up. It's already been 45 minutes, but there's the lesson in a nutshell. Please make sure you have everything down. I'm going to put a Zoom call up for 10 o'clock this morning. So if you want to try to meet me, I will have a Zoom call open. I'm happy to help walk you through anything that you should need. I hope you found this lesson to be a little bit more interesting and doable, because I know that last topic, number 1, had some challenges for us in there. Graphing can be a lot of fun, so we want to make sure we get this y-intercept solid before we move on to the next concept. All right, guys, enjoy your Friday. Hopefully I'll see some of you on our Zoom call at 10 o'clock. Have a wonderful weekend.